Good day each and everyone. We will be discussing the Zener diode. So first, what is Zener diode? It is also known as a breakdown diode that is heavily doped semiconductor device and is designed to operate in the reverse direction. So when the voltage across the terminals of the Zener diode is reversed, the potential reaches the Zener voltage and the junction breaks down. So, the current flows in the reverse direction. This effect is known as the Zener effect.
The person who described the Zener diode. Clarence Melvin Zener was the first person to describe the electrical properties of the Zener diode. He was the theoretical physicist who worked at Bell Labs. As a result of his work, the Zener diode was named after him. He first postulated the breakdown effect that bears his name in a paper that was published in 1934.
How does a Zener diode work in reverse bias? It is operate just like a normal diode when it is forward bias. However, a small leakage current flows through the diode when connected in reverse bias mode. As the reverse voltage increases to the predetermined breakdown voltages, current starts flowing through the diode. The current increases to a maximum which is determined by the series resistor, after which is stabilized and remain constant over a wide range of applied voltages.
So, avalanche breakdown occurs in a normal diode and Zener diode at high reverse voltage. So, avalanche breakdown is process of applying high voltage and the increasing of free electrons or the electric current sa semiconductor and insulating materials. Yun yung tinatawag na avalanche breakdown. So, Zener breakdown is when applied reverse bias voltage across closer to the Zener voltage. The electric field in a depletion region gets strong enough to pull electrons from their valence band. The valence electron that gain sufficient Zener diode is temporary breakdown of the PN junction sa diode nun. So, yung diode nun which not destroy yung mismong diode. Pero, once ma-reverse or reverse voltage is ma-remove, yung PN junction is mare-regains na siya sa original state niya. So, ganun. So, the reverse of yung value of reverse voltage which the Zener diode sa PN junction, mati-take place yun. Yun naman yung tinatawag na Zener voltage. So, Zener voltage nga takes place in highly doped PN junction diodes.
So let's tackle about the avalanche breakdown and the Zener breakdown differences. So while these both breakdowns can occur simultaneously, the main difference of these two is their mechanism of occurrence. Zener breakdown occurs because of the high electric field, while the other one, the avalanche breakdown, occurs because of the collision of free electrons with the atoms.
Is yung forward and the reverse bias. So, forward biasing, application siya ng voltage across sa diode and nagpermits ng current to flow freely or easily. So, while the reverse bias naman is application naman of voltage across the diode in opposite direction. Sa setup naman ng forward bias, so yung P side of the diode is nakatouch siya to the positive terminal and yung sa P side naman is nakafix na siya sa negative side of the battery. Yung forward bias din, yung voltage niya is pwedeng, yung voltage na meron siya sa may anode is higher than the voltage naman ng cathode side. And the current naman na nagpo-flow from the P-type or yung anode and the N-type or the cathode is considering na pa-forward yung direction. Ina-allow niya yung pag-flow ng current doon sa both P-type and N-type. So, next naman is yung reverse bias. When reverse voltage is applied to a Zener voltage, a small reverse saturation current to flow across the diode. Reverse bias, sinasabi nga na it refers on how diode dun sa ginamit na circuit, how diode used in a circuit. So, if diode is a reverse bias, the voltage at the cathode is mas mataas o mas higher dun sa anode. So therefore, no current will flow until the electric field is high. Then the diode breaks down. So yun.
Application of Zener diode. Zener diode as voltage regulator. The Zener diode is used as a shunt voltage regulator for regulating voltage across small loads. The Zener diode is connected parallel to the load to make it reverse bias. And once the Zener diode exceeds the knee voltage, the voltage across the load will become constant. The breakdown voltage of Zener diodes will be constant for a wide range of currents. Another application of Zener diode is in overvoltage protection. When the input voltage is higher than the Zener breaker voltage, the voltage across the resistor drops, resulting in a short circuit. This can be avoided by using the Zener diode. And lastly, Zener diode in clipping circuits. Zener diode is used for modifying AC waveform clipping circuits by limiting the parts of either one or both the half cycles of an AC waveform.
The specification of the Zener diode. So first is Zener breakdown voltage. The Zener breakdown voltage is the reverse breakdown voltage ranges from 2.4 volts to 200 volts. Sometimes it can go up to 1 k volts, while the maximum for the surface mounted device is 47 volts. Then the second is the maximum Zener current. The maximum current is calculated by dividing the power rating by the Zener voltage. Current is equal to power over voltage. So the 3 watts over 12 volts. The 3 watts is represent the power. Then the 12 volts is the voltage. Then the answer is 0.25 amperes. This is the current. So next is the minimum Zener current. The minimum Zener current is that current which you want to still flow through the Zener when the maximum load current is being taken. So the current of minimum Zener current is 0.25 milliamperes. Then next is the power rating. The maximum power the Zener diode can dissipate given by the product of voltage across the diode and the current flowing through. Typical values are 400 milliwatts, 500 milliwatts, 1 watts, and 5 watts. For the surface mounted, 200 milliwatts, 350 milliwatts, 500 milliwatts, and 1 watts are typical. Then the next is the temperature stability. The Zener effect has a negative temperature coefficient while the impact effect experiences a positive coefficient. The two temperature effects are almost equal at 5.5 volts and they cancel out each other to make the Zener diodes weighted at around 5.5 volts, the most stable over the wide range of temperature conditions. Then next is voltage tolerance. Standard tolerance are characterized as B selection for positive negative 2% and C selection for around positive negative 5%. To address the demand for higher precision, Nexperia recently introduced a broad portfolio of a selection Zener diode with a tolerance of positive negative 1%. So the last is Zener resistance. Zener impedance is the equivalent series resistance of a Zener diode. When it is conducting current, it is calculated as change of Zener voltage that occurs as a result of tiny change in Zener current. Zener impedance should ideally be zero, but in reality, a Zener diode has some impedance.